All right, we're on number 4. First thing we're going to do is put it in slope-intercept form. So I'm going to take 3x plus y equals -4. I want to get y alone. Subtract 3x from both sides. Cancel. Y equals -3x minus 4. Good to go. And then I'm going to take 3y equals 1/2 x minus 6. Now watch closely. I know you guys all want to have a cow because there's a fraction in there. If I want to get y alone, I divide every stinking term by 3. This is easy. This is easy. This is -2. 1/2 x divided by 3. I'm going to go over here. Okay, how about down here? 1/2 x divided by 3. Let's call this 3 over 1. You know how to divide fractions. You multiply by the reciprocal of the second fraction, and then you multiply straight across. 1x times 1 is 1x, and 2 times 3 is 6. So we get 1x over 6, which we can call 1/6 x, because this is our slope. So here are our two equations. Y equals -3x minus 4. If I'm going too fast, pause it, back up, look at it again. And y equals 1/6 x minus 2. Now I'm going to graph those. So I'm going to begin at -4 on the y-axis. And my movement is going to be down 3 over 1. Ooh, yikes, I'm going to run out of room. Well, I can figure out where that is, but I want to go the other way, so I'm going to go up 3 and back 1. That's still -3. Up 3, back 1, up 3, back 1, and there's my sweet straight line. All right, and then I'm going to graph y equals 1/6 x minus 2. So I'm going to begin at -2 on my y-axis. I'm going to go up 1 and over 1, 2, 3, 4, 5, 6. I already ran out of room. How about if I go down 1 and back 1, 2, 3, 4, 5, 6. There we go. And when I do this, it looks like my point of intersection is really close to -1, -2. It doesn't look exact. Let's try -1, -2 just for kicks and see what happens. So I'm going to take, now I can plug it back into these equations or these equations. It doesn't really matter. I think I'm going to go with these equations just for fun. So I have 3x plus y equals -4, and then I'm going to plug it into 3y equals 1/2 x minus 6. Let's see what happens here. So I'm going to plug in -1, -2, and I'm going to get 3 times x, and that's -1, plus y, which is -2, equals -4. Well, 3 times -1 is -3. If I combine 3 negatives with 2 negatives, I'm going to get 5 negatives. And that is not true. Pretty stinking close, but it's not true. So you know what I'm going to determine here? This point of intersection is going to be some fractional numbers, which I can't really determine from a graph. So I can only really estimate what my point of interception is here. So this is a really good example of why graphing isn't the best way to solve a system. If I were to solve this algebraically, I would get my exact answer, but graphing it isn't the best solution. So this isn't a solution. I'm not really sure what the solution is, but I don't think graphing is the way to find it. So I'm going to go on to number 5. Didn't see that coming, did you? Number 5, I'm going to put it in slope-intercept form. X equals 2 minus 2y. I want 2y alone, so I'm going to subtract 2. And I have negative 2y here, and I have x and a negative 2 here. These are not like terms. I want y alone, so I'm going to divide by negative 2 every stinking term. And y equals, this is 1x, so my slope is 1 over negative 2 x. Negative 2 divided by negative 2 is positive 1. Now I'm going to flip it over because it's an equation, and I can. So I'm going to put my y over here, but I have to make sure I don't change the value of any of my terms. So I'm going to keep my 1 over negative 2x and my positive 1. And that's my equation in slope-intercept form, the first one. So the first one is y equals negative 1/2 x plus 1. Now remember, when I graph this slope, I can go up 1, back 2, or I can go down 1 and over 2. In other words, I could graph it like this and still have a negative slope, because a positive divided by a negative is a negative, and a negative divided by a positive is a negative. Okay, let's look at the other one. Negative 3 equals negative 2x minus 3y. And I want to get y alone, so I'm going to circle that term right there, and I'm going to get rid of negative 2x by adding 2x to both sides. These cancel out. I have a negative 3y. These are not like terms, so I'm going to bring them down one at a time, and I'm going to bring my x term down first. Divide every stinking term by negative 3. This cancels out. Y equals 2 over negative 3x. Negative 3 divided by negative 3 is positive 1. This is perfect, but it's backwards, so I'm going to rewrite it. Flip it over, make sure you don't change the value of any of your terms. And there is my equation in slope-intercept form. Y equals 2 over negative 3x plus 1. Okay, so there's my two equations that I'm going to graph. I'm going to begin at 1 on the y-intercept, and my movement is going to be down 1 over 2, down 1 over 2, down 1 over 2, or up 1, back 2. Up 1, back 2. It's still on my straight line. It's still going downhill, which means it's a negative slope. And then I'm going to do plus 1 again, and I'm going to go up 2 and back 3, up 2, back 3, and I'm going to go down 2 and over 3 and down 2 and over 3. Those lines are really close. Negative 1/2 and negative 2/3 are really similar slopes. Now this is interesting. Notice that I have a y-intercept of 1 and a y-intercept of 1. Well, guess what my point of intersection is? I don't even have to verify this. If my y-intercept on both of those is 1, I know for a fact that's where they're going to touch or intercept. I mean, it's obvious to see it, and I know just by looking here that, of course, that's true. These are only going to intersect one time, and they both have a y-intercept of positive 1, so hello, that's their point of intersection. Okay, these next three are trickster, but they're not too tricky for us because we're smarter than most people. These are inequalities. So I'm going to start by once again putting them in slope-intercept form, which is really necessary with an inequality, so I can use my greater than is above the line and less than is below the line trick. So number 6, the first one's in slope-intercept form. The second one will be so easy. And don't forget, when we're manipulating this, we got to remember our random rule. All we have to do here is subtract x from both sides. Don't have to reverse the symbol because we